Alright, we're here on week 10 for our RCX inputs and our temperature sensor work, as well as water heating. So again, this is the equipment setup and a little bit about the programming you'll need to take temperature information in from our thermometer and then use it to control the output. So let's get started. So the RCX, of course, has its ABC outputs that we've been using to control the relay and the heater from week 9. This time we're going to start attaching an alternative input. So on sensor port 1, we're going to attach our temperature sensor. And so this is a resistor and a thermistor combined, and I'll show you that in just a second. But this is exactly like the commercial temperature sensor that comes with the RCX and the Lego products. And so we're going to use this on our setup and use it to measure something that's close to degrees C. And so we're going to have to write a program that tells the RCX to read temperature on input 1. We'll also go back this week, set up the voltage divider for the relay to drive the heater for the second part of our work this week, where we run the heater for 30 seconds and see what kind of temperature change we get on the tank. So let's take a look at the wiring from the temperature sensor back to the RCX. So here's our temperature sensor. Again, inside here's a small thermistor. It's a negative temperature coefficient device, so when you raise the temperature by grabbing the thermistor, its resistance drops down. Also inside here is a second resistor. You can actually see it a little bit here. So that pair of resistors leads back to the RCX, and so the green and white wires go to a terminal block and they're connected to the red and white wires here. And so we'll bring the red and white wires back over to our fish tank panel and get them installed. Let me grab my screwdriver. Get them set up here. There's red, white. So again, we're coming from the thermistor and we need to get back to sensor input 1. And so we'll plug this in on sensor input 1 and also connect these. So this is one side and side 2. So that completes our wiring. So let's take a quick look at the RCX. Turn it on, and again, it's pressing the view buttons. You moves the caret around so that it'll display temperature. And the decimal place is missing, so this is actually about 25 degrees. It varies a little bit here, and you'll see that in class as well. To get it to read this temperature, you'll need one program. And so take a quick look at that simple program here. So will be the one item you're going to install is a wait for command, and so that'll be found on the wait for, and there are 4 temperature sensors here. So degrees C is what you're looking for, and you can use either one of the degree C commands. I chose to use the wait for decreasing command here. So all this does is tell the RCX what's connected. I told it it was connected to port 1, and then closed the program and then loaded it in the RCX. The last thing is I actually ran the program once. You have to make, if it isn't reading properly or maybe not be displaying properly, if you run the program once, that's usually satisfactory. Alternatively, you might also have to press the view button and cycle through what the display is until you get back, and that may also make a difference. So that's how you do the setup for this first experiment. Alright, so for our temperature sensor calibration, we're going to compare 5 temperature samples against the thermometer. And so the 5 samples are, we've got in the classroom, we'll have ice water, room temperature water, and hot water. And then we'll make mixtures from those to get 2 more data points. You're going to collect data for actual temperature and compare it to the RCX reading. Alright, so again, our samples are right here. We've got ice water, room temperature water, and the hot water, and so we'll mix the other 2 later. So here's the ice water. Right now we're reading about 25 degrees C on the thermometer that's in the open air. So you stick that down in there, make sure your thermometer is also on, stick them in there as well. And so the temperature is changing on this thermometer, and the RCX reading is also changing. So they won't be the same, but this is the data you're going to graph. And so this one seems to have settled, just seems to have taken a few seconds. So we've got 23 degrees. This is not actually freezing water. You'll find data much differently. And so collect both pieces of data off of the Taylor thermometer and then also off of the RCX. The RCX will vary, so pick your best value. So you set that one aside. Do the room temperature water the same way. Again, these are going to display right now. They're going to display identically because all the water sources are the same. You'll be putting different sources in. Again, take this reading and this reading for the room temperature water once it stabilizes, and one more time for the hot water, and wait for it to stabilize as well. So, since these are all the same, we'll run through this, set these aside. Now we'll mix the hot water and the room temperature water for our other data points, so about half of each, to get some alternative data. So again, stick the thermometer in, wait for it to stabilize, and read both values and record them. And finally, of course, our last data point, mixing the room temperature water and the ice water. And complete your final data point. So, collect this data. Make sure and observe how long it takes for the samples to settle. The next thing you'll be doing is graphing the RCX display value versus the actual value. Let's take a quick look at a couple of graphs here. I want to make it clear what you need to do. So again, I did say that you'll create a graph from that data. Excel is the best for doing this. You'll graph the RCX display on the y-axis and the actual temperature on the x-axis. And then in Excel, you can create a trend line that models this data and add that formula on the chart. If you don't know how to do that, we can show you that in class. And so it'll create a y equals mx plus b line. You'll also need the opposite of that, so the actual value versus the RCX display. That way, if you know what RCX display reading is, you can tell me what the actual temperature is. Alternatively, if you know you need a particular temperature on the actual display, you can find out what RCX display corresponds to that. So this will be used throughout the rest of the semester. So gather good data, create some good graphs from these activities. Alright, so now on to the heating side of this, the second portion of week 10. Again, we're going to set up the same circuit as we did last week, the relay activating the heater. And we're going to set it up so that we can run the heater for 30 seconds. And more importantly this week is do the calculations for what that temperature change in our water tank is going to be. We're actually going to have the tank filled up with water. So let's slide this over here. Our general process is we need to arrange the pump to recirculate the water. You need to figure out how much that tank holds so that we can estimate how much of a temperature change we'll get. Fill it with room temperature water, make sure and remove the bubbles from the pump. And then what you'll have to do once you have that volume, you'll have to figure out how much energy will be added to the heater in 30 seconds. So your data from week 9 in terms of the energy, the power of the heater is going to come back into play here. So make sure and grab that data. Finally, with that calculation of how much temperature change, how much energy you have, you can figure out how much temperature change you should occur. And then you can actually run a test to check it. So you're going to check the starting temperature and then turn on the heater. That's the type of data you're going to collect is going to be like this. So once we've got this organized, and I'll show you that in a second, you're going to start at 0 with a known temperature reading. And again, since we've calibrated now, we don't need the actual temperature. We can just use the RCX display. And you're going to run the heater for 30 seconds, taking temperature readings along the way. But once that heater shuts off, you should continue to take data until it's stabilized. So after that, you're going to graph this data and figure out what temperature change actually occurred and compare it to your calculations. So let's take a look at this setup. So the heater from last week is now connected to the terminal block much the same way as the temperature sensor was, and so it's going to be placed down in the tank. Its wires again come back over, connect like we did last week to the secondary side of the first relay. So we're going to want to clean up these circuits this week, and we'll talk a little bit about that in class. We need to get rid of some of these long wires and make it neat and easy to troubleshoot. So our RCX is going to be set up to run the relay, so I've got it programmed to run output A, and you should hear it click and the light come on. So this is working just fine, and the program that I've got will run it for 30 seconds. Alright, so let's figure out how much volume is in the tank. You'll need that to do your heater calculations, and so we're going to set this aside for a second. And so earlier I weighed this volume of water. It's 313 grams, and so I'm going to start out by filling up the tank most of the way. I'm going to go ahead and start the pump. We want to make sure we get enough bubbles out of the pump. So right now I've got the pump set up to recirculate, and so I'm going to hit the reset button here. And I'm going to test it once, let some of those bubbles come up out of there. And so that's pretty good. So I'm going to fill this up until it overflows. Oops. Alright. So now I've allowed the tank to, I filled it up all the way and allowed it to overflow. So this is the normal operating level for the tank, and so I take this mass, we'll measure this again and subtract this from the original 313 grams. So that's our, that'll give us the volume on our tank. And of course 1 gram is a milliliter. We're spraying a little water out here. Wow, it's a lot of pressure right here. Alright, so that'll give us our volume in the tank, and you can do your heater calculations from there. Stop that. Let's see. So again, you would take your volume in the tank and the energy put in by the heater, and you should be able to figure out approximately how much temperature change you should expect when the heater is ran for 30 seconds. So again, check your starting temperature, turn on the heater, and record the temperature along the way. Again, the heater will shut off at 30 seconds, but you should record the temperature until you feel it's stabilized. That's it for week 10. That's enough data to get you going.